problem says a chainsaw sculptor would like to estimate with 95% confidence the average number of gallons of gasoline that he uses while sculpting a moose. He selects a random sample of 20 logs to work with and records the amount of gas he uses for each sculpture. The sample mean turns out to be 1.4 gallons with a standard deviation of 0.6 gallons. Find the 95% confidence interval for the mean number of gallons of gas used. So the question is to find the 95% confidence interval. Now, if you're finding a confidence interval, you have to ask yourself, am I finding a confidence interval about a proportion or a mean or whatever? In this case, it says to find the confidence interval for the mean. If we're finding a confidence interval about a mean, then we have to find what our sample size is. If our sample size is at least 30, we would use the normal distribution to estimate that interval. If the sample size is less than 30, then we would use the t-distribution. We see here that our sample size is 20, less than 30. So the formula for calculating this confidence interval will be x bar plus or minus t times s over the square root of n. This part here t times s over the square root of n is called the maximum error of the estimate. We're going to, I can make a little bit better minus symbol here. We're going to calculate this maximum error of the estimate, add it to x bar, and then subtract it from x bar. That'll give us two interval endpoints. If we were to think about this on a number line, x bar would be here in the middle. We would add t times s over the square root of n, and we'd wind up over here at x bar plus t times s over the square root of n, and then subtract t times s over the square root of n, and wind up back here at x bar minus t times s over the square root of n. And then we would find our 95% confidence interval. Okay, S we know. S is 0.6. N we know. It's 20. T is what we don't know. In order to find T, we'll look it up in a table, and we'll have to know what the number of degrees of freedom are. The degrees of freedom are the number of data values that are free to vary, and the estimates still remain valid. Well, when we're calculating a confidence interval about a mean when our sample size is small, and it's a one sample problem, like as this one is, then the number of degrees of freedom will be one less than the sample size. In this case, then 20 minus 1, or 19. We'll look this up in a table that you would find in most textbooks, very similar to this one here, where we would have confidence intervals here across the top, with some percentages given in the columns, 80%, 90%, 95%, 98%, 99%. And then along the far left column, we would find the number of degrees of freedom. Well, we're doing a 95% confidence interval. So our column that we would be looking in would be this one here. And we have 19 degrees of freedom. 19 degrees of freedom corresponds then to the 95% confidence interval column, right there where it says 2.093. So our number of degrees of freedom then, 95% confidence interval, number of degrees of freedom 19, our t value is 2.093. So t equal to 2.093. So we'll calculate this maximum error of the estimate, t times s over the square root of n. That'll be 2.093 times 0.6 divided by the square root of 20. this is going to give us 0.2808. For right now, I'll just do four decimal places, and we'll talk about the significance. How far we should round in just a second. So what we're going to do is we're going to take x bar, and we're going to add. So we'll subtract it to get the left endpoint, and then add it to get the right endpoint. So x bar plus or minus t times s over the square root of n. So we'll go x bar minus 0.2808, and then x bar plus 0.2808. X bar in the problem was 1.4, so we'll have 1.4 minus 0.2808 and 1.4 plus 0.2808. Now, I went out to 4 decimal places here. That's more than we needed, but I wanted to illustrate something here. Our sample mean is rounded to the 10th place. So that means then that our interval estimate endpoints need to be rounded to the same. So if I take more than 2 decimal places there, then I'm not violating any rounding rules, because I'm not supposed to round until I get to the very end. But if I'm going to round to 1 decimal place, then really I only need to go out to 2 and then round. But in any case, this is going to give me, if I round it to 1 decimal place, 1.1 to 1.7. So in other words, my interval endpoints are 1.1 and 1.7. And the way that we would interpret this interval then is we would say we are 95% confident that the actual actual mean number of gallons of gas used by this sculptor to carve a moose is between 1.1 gallons and 1.7 gallons. Okay, now I also have a calculator here that we can use to perform these calculations. That calculator can be found at www.volstate.edu/jmore/calculators/calculators.htm. And I'm going to use the small sample t interval calculator, and I'm just going to type in the stuff that I got from the problem. The sample mean was 1.4. The sample standard deviation was 0.6. The sample size was 20. The t-value is 2.093. The alpha level is 0.05. And now I'll just hit calculate. And it'll give me 1.1 to 1.7 if I round to 1 decimal place again.